Hello everyone, welcome to class 10th. Because of the fact that we are not able to have one-to-one classroom sessions because of the coronavirus and to contain its spread, I thought let's come up with this video and let's start with the classes at least just to get the ball rolling, because I understand that we are losing on time as well. So I think it's important that we start at least whatever the efforts we can make in the direction of starting with your syllabus and just preventing any further time loss. So I thought I'll use the online method and we will start with the syllabus for class 10th. So what I'm going to do is I'll be starting with maths chapter polynomials. Polynomials is a chapter that you have already done in class 9th and you have some basic idea about it, right? So what we are doing is starting with the chapter polynomials. Also, I would want the parents as well as the students to please see this video and please come up with the suggestions as to how can I improve on this, right? So as I wrote on the group also that I cannot go live through a DSLR, so I just want your feedback on how can I make these sessions probably more informative, and in case there is anything lagging in this, maybe the clarity, maybe the background noise, maybe any such feature, and any suggestions or tips that you would like to give, and please let me know. All right, so we'll start with the chapter polynomials. Before moving on to what class 10th has in polynomials, I would just like to recollect what we already done in class 9th. Now, we understood in class 9th what a polynomial is. Over here, I have the four expressions. First is px equals to 3x squared minus 2x plus 5. And by the look of it, I can see that, okay, this is a trinomial of degree 2. This is a polynomial with three terms, three unlike terms. So this is a polynomial, a trinomial. And this has the degree 2 because the variable's power is 2. The second expression, px equals to x cubed minus 5 root x minus 3, is not a polynomial. Why? Because we know from class 9th that the variable cannot have the power in the form of decimals or fractions. So over here, x has a power of root. So it's root x translates to x to the power 1 by 2, and 1 by 2 is not a whole number. So this expression, since this is not a polynomial, this entire expression ceases to be a polynomial. ये polynomial नहीं है. Now the same goes for the third expression, px equals to root 2x square minus 2 root 3x minus 5 upon x. Nothing wrong with this expression because the square root sign is not on the variable. The square root sign is on the constant, which is fine. Over here, x is having a power of 1, so this term is also a polynomial individually. But the last term, minus 5 upon x, I can write minus 5 upon x as minus 5 x to the power negative 1, and negative 1 is not a whole number. So this entire expression is again not a polynomial. If we look at the fourth expression, px equals to 4 times x to the power 5 minus 3x squared plus root 3x. This is a polynomial because all the terms that has the variable, the power of the variable is a whole number. This is what we learned in class 9th. I thought we should just revisit it. And next, what we understood in class 9th was trying to find the zeros of a polynomial. Now what exactly are zeros? I'll take an example. Suppose I have a polynomial px equals to 3x squared minus 2x minus 1, right? Now over here, this is a polynomial first of all because we have the basic checks, and we can see that the variable over here has whole numbers as its power, as their power. So yes, it's a polynomial. Zeros of a polynomial are basically those values of the variable which when substituted in this polynomial will make the entire polynomial 0. For example, in this case, if I substitute the value of x to be 1, so I'll get p of 1 as 3 times 1 square minus 2 times 1 minus 1, which is 3 minus 2 minus 1, which gives me 0. This tells me that the entire polynomial becomes 0. The value of the polynomial becomes 0 when I substitute the value of x to be equal to 1. So I can say that x equals to 1 is a 0 of px. So this is how you define a 0 of the polynomial. Values of the variable at which the polynomial becomes 0. Now the question is, how many values can a variable have at which the polynomial gives the value of 0? And it turns out, I think you guys must be aware also, it turns out that whatever the degree of the polynomial is, I can have those many maximum number of zeros possible. That means those many maximum values of the variables are possible at which the polynomial will be 0. Okay, so this does not mean that every polynomial will have those many zeros compulsorily. For example, if I have a polynomial 3x squared plus x plus 5, and I say, okay, since this polynomial has a degree 2, this will have 2 zeros. No, that's not what I'm saying. It might be that this polynomial doesn't have any zeros, in the sense I cannot find any value, any real value of the polynomial of the variable at which the polynomial becomes 0. It can happen. But if there is a polynomial with degree 2, it can have the maximum number of zeros to be 2. It may have 1 0, it may not have any 0, but the maximum number of zeros will always be equal to the degree of that particular polynomial. Right? I think we know about that. Perfect. Now, moving to what we have to learn in class 10th. Class 10th ke liye, I will give you an example of a polynomial. Again, let's see. I have another polynomial px, and this is x square minus 7x plus 12. And in case the question is find the zeros, we can find the zeros by factorization, and the first step to finding a zero of a polynomial is, first of all, equate the polynomial to 0. Right? Once I've done that, I'll write x square minus 7x plus 12. This is just an example that I'm taking. So x square minus 7x plus 12 equals to 0, which can be now factorized. You know how to factorize splitting the middle term or by using an identity. Right? So over here I can see this comes out to be x square minus 4x minus 3x plus 12 equals to 0. Splitting the middle term, you guys have been doing it since class 8, so I don't think this should be a problem. So this comes out to be x into x minus 4 minus 3 into x minus 4 equals to 0, which gives me x minus 4 into x minus 3 equals to 0. Alright, I have just factorized the particular polynomial, not found zeros yet. Now please understand, on the LHS, I have two terms, rather I have two factors of this polynomial. The initial polynomial that I had, x squared minus 7x plus 12, इसके दो factors हैं मेरे पास, x minus 4 and x minus 3. Okay, and on the RHS I have zeros. That means two terms are being multiplied together to give me the result as 0. This cannot happen with a non-zero factor, meaning if the product of two terms is 0, either of the term must be 0. If both are not 0, then I cannot have the product to be 0, right? So either of the term, either x minus 4 must be 0 or x minus 3 must be 0, which gives me x to be equal to 4 or x to be equal to 3. These are the two zeros of this particular polynomial. right? We know how to find this as well. 9th क्लास में मैंने कराया था आपको. Now 10th क्लास में क्या है? 10th क्लास में मुझे इन जीरोस के बीच में रिलेशन चाहिए. मतलब पहली चीज, पहले जीरो को हम लोग अल्फा से डिनोट करते हैं और दूसरे जीरो को हम लोग बीटा से डिनोट करते हैं. Alpha and beta, they are Greek alphabets, and you can use these by convention, not as a rule, but by convention you should use alpha and beta to be representing the two zeros of a particular polynomial. 3 zeros अगर होते डिग्री 3 वाला polynomial होता तो अल्फा, बीटा और गामा यूज करते हैं. जब आएगा तब मैं आप लोगों को बताऊंगा, राइट? सो अभी फिलहाल के लिए इस polynomial के मेरे पास 2 zeros आ गए. ऑलराइट, let me try and find the sum of the two zeros. अल्फा और बीटा मेरे पास है. अगर मुझे sum of zeros निकालना है, so I'll have alpha plus beta, which turns out to be 4 plus 3, which is equal to 7, right? और अगर मुझे प्रोडक्ट निकालना होता, प्रोडक्ट alpha into beta, which should have been 4 into 3, which is 12, right? Okay, अब ये क्यों निकाला हम लोगों ने, right? तो क्या जरूरत थी इसका सम निकालने की, प्रोडक्ट निकालने का? It turns out that there is a very interesting relation between the sum of the zeros and the coefficients of the variable over here. And it's not a coincidence that if you suppose I have the polynomial x square minus 7x plus 12. If I take the coefficient of x, what is the coefficient of x over here? Minus 7. So if I take minus 7 and divide this by the coefficient of x square का coefficient हमारे पास है 1, राइट? हम लोगों ने x का कोएफिशिएंट लिया और x स्क्वायर के कोएफिशिएंट से उसको डिवाइड कर दिया और उसके आगे एक नेगेटिव साइन लगा दिया. जो आंसर आएगा, नेगेटिव ऑफ minus 7 gives me 7 and 7 happens to be the sum of the zeros. Trust me, it's not coincidence. I can prove it for you also. This is not a coincidence. Also, if I take the constant term, not this one, the constant term is 12, right? If I take the constant term and divide this by the coefficient of x squared, which is 1, the answer that I get is equal to the product of the two zeros. Interesting? Well, you might think it's a coincidence. It's not. I'll give you another example. So 6x square plus x minus 2. This is another polynomial that I have, and what I'm trying to do is now trying to find its zeros and try to find the relation between the zeros and the coefficients. Okay, so I understand looking at the term that I need to factorize this and split the middle term. So the first step is equating the polynomial to 0, which gives me 6x square plus x minus 2 equals to 0. Now I need to split the middle term, in the sense I need to split x in two terms which upon adding will give me x and which upon multiplying should give me the product of the first and the last term, which is 6x square into minus 2, which is minus 12x square. And I can use the terms plus 4x and minus 3x. These two terms will multiply and give me negative 12x square, and which will be added to give you positive x. So this happens as 2x. I can take common from the first two terms. This will be 3x plus 2, and I can take negative 1 common. This will be 3x plus 2, gives me 0. I can take 3x plus 2 common and I'll get 2x minus 1. So these are the two factors that I have. Now if the first factor is 0 then x will be negative 2 upon 3. If the second factor is 0, then x will be equal to 1 upon 2. I can call the first one as alpha, so alpha comes out to be minus 2 by 3, and beta in this case comes out to be 1 by 2. And let's see if we can now establish the relationship. First of all, let me just erase this section. Let's see, so alpha plus beta will be negative 2 over 3 plus 1 upon 2. I can take the LCM as 6, so this is minus 4 plus 3, which is negative 1 upon 6, right? And alpha into beta will be minus 2 upon 3 multiplied by 1 upon 2, which gives me negative 1 upon 3. So alpha beta is minus 1 upon 3 and alpha plus beta is negative 1 over 6. Now let's see if we can have the same relationship as I did in the previous question. What I'm doing is taking the coefficient of the term over here which has x. So इसका coefficient 1 है, इसको डिवाइड करते हैं x स्क्वायर के कोफिशिएंट से जो कि 6 है और इसके आगे नेगेटिव साइन लगा देते हैं. The answer is negative 1 over 6 and this is equal to the sum of the two zeros, right? इसमें देखते हैं मेरे पास कांस्टेंट टर्म है -2, so constant term is -2 or negative 2 and the term which is the coefficient of x square is 6. So negative 2 over 6 gives me negative 1 upon 3 and this is equal to the product of the zeros. So I shown you two examples. This can't be a coincidence now. So this is a formula that you have to remember. It turns out that if I have to find the sum of the zeros, that is alpha plus beta, is equal to negative of the coefficient of x divided by coefficient of x square, right? And if I have to find the product of the zeros, that is alpha into beta, this is the constant term divided by the coefficient of x square. And to make it easier to remember, if I take the standard form for the standard polynomial of degree 2, which is ax square plus bx plus c, where a, b and c are real numbers, then I have the sum of the zeros to be negative of b upon a and the product of the zeros to be equal to c upon a. This is what the first section of this chapter is all about. What I want you to do is take polynomials of degree 2, right? I'll give you some examples over here and try to find the relation between them. I will be sending you homework on the group and you can practice this and then come back to me. I will start with the second video after that. Alright, all the best guys.